So like the warm-up, what we're doing today is graphing lines, but they're special kind of lines. And before we get started, go ahead. You don't need a calculator today, so I'm not going to make you get up and go trade your phone. But what I do want you to do is put your phone away so that I can't see it. So don't just put it in your lap, like put it in your backpack. We've only got 3 problems we're doing together. And then I'm not going to micromanage you. So put your phone away while we do our notes. Okie dokie. So also quick reminder about the bathroom pass. I would really prefer that you wait until I am done teaching. We only have, like I said, 3 problems that we're going to do together, and then you can go. Most of you don't know the concepts that we're doing. That's why we're in college prep math. So stay through the notes, and then if you need to go, you can go. You'll write your name and the time. If you're going anywhere other than the bathroom, come and ask me for a different pass. So today we're going to talk about, they call them systems of equations. So you have a body system because there's lots of different things in your body that makes it work. It just means there's more than one thing. So a system of linear equations simply means that more than one line is graphed together. So you could have 2 lines, 3 lines, 5 lines, you could have multiple lines. We're only talking about linear equations, but they don't have to be just lines that cross each other. It could be a parabola or a U-shaped graph and a line. It could be anything. The answer to a system of equations is where the lines cross. They could also just touch. And the math word for that is intersect. The lines can cross, they can touch, where they intersect, it's all the same thing. So we have this chart, and the chart kind of illustrates 3 like different types of solutions, 3 different situations that happen. So this is primarily what happens, is that you got 2 lines, they intersect, and right there, that is the one solution. So the number of solutions, there is 1. For these, it's important to know that the slopes are different. Another thing that's different is the y-intercept. Slopes are different, y-intercepts are different, they are different lines. Amir, put your phone on the wall. I know. Literally 3 examples. So this is the primary situation that you have. You got 2 lines, they're different, they intersect, and the answer is where they cross. So it's naming that point. Another situation that happens, what kind of lines are these? Parallel, very good. These are parallel. And how many times are those going to cross? Never. So the number of solutions, there are none. So we learned about parallel lines. Does anybody remember what's special about the slopes? They're the same. But the y-intercept will be different. So the slopes are the same, but where they cross the y-axis, it'll be different. The last situation. Do you see two lines? No. You only see one, but technically there are two. They are actually the same line. That's weird, but it's a type of system. So they're actually the same line. So where do they touch or cross each other? They're always touching. So the number of solutions, it's more than you can count because they touch at every point along the line. So the number of solutions for this one, we write it as infinitely many. And we can shorten that to IMS, infinitely many solutions. IMS, infinitely many solutions. When you have the same line, they cross everywhere and there are infinitely many solutions. So for this one, you have the same slope and the same y-intercept. Everything is the same. They cross everywhere. So question one, this should look really familiar. Does it look familiar to you at all? It's the warm-up. So we're going to graph this. I'm going to graph it on the board, but you should also be able to graph it because we literally just did it. So we're going to graph both of those lines. And if you want, it could be now or it could be at any point. If you ever want to use, I have colored pens, I have colored markers, I have colored pencils. If you want to draw your lines in different colors, you are welcome to. Do your graphs look like mine? Okay, so the answer, what is the answer? We just wrote it. It's bold, it's at the top, right above your little grid. What's the answer to a system? One solution, and it's where they cross or touch. So I can see that they cross or touch. What is the name of that point? How do we get there? So when we name our point, it has to be an X, comma, Y. So we have to go along the X-axis first. What is the name of this point? I think I heard Juliet say it. Who else knows what the name of that point is? -2, -3. You have to do the X first and then the Y. So the next three problems on the front page are going to be similar. And so if they cross, your answer is the point where they cross. If they don't cross, then you say there's no solution. If it ends up being the same exact line, then it is infinitely many solutions. One thing that I want to do, I forgot to put this up here, so let me find them. Real quick before we move on to the other problems. Question 3 and question 4. The first equation is good. It's in y equals form. But what about this one? Is that in y equals? No. So we will have to fix anything that's not in y equals form. So it's not in y equals form because the y is being multiplied by 2. So how do we undo multiply by 2? Divide by 2. And you have to divide everything by 2. So what you end up with, and what is 4 divided by 2? So that is that equation once we fix it. You will have to do the same thing for the second one on number 4. You'll have to divide by 3, divide by 3. Go ahead and do that before we move on to the next problem. Go ahead and fix number 4 so you don't forget. Okay, and then we're going to flip on to the back, the next section of problems. Those of you that have taken TSI, nobody likes this type of problem. Everybody struggles with it. So it says, if x plus y is 24 and y is equal to 5x, what is the value of y? This is technically a system of equations because they're giving you 2 equations. And finding x or y is really just finding that point where they intersect. We're not graphing them. We're going to find this algebraically. So it says if x plus y is 24 and y is equal to 5x, what is the value of y? Well, before we can even figure out y, what we have to do is we will substitute and we will take this y is equal to 5x and we will plug it in right there. So I'm going to rewrite this problem. So all I did was replace y with 5x because it says y is equal to 5x. So let's replace it. When we do that, we have a pretty simple problem to solve at this point. We have 2 x's. We can put them together. If we have 1x and then we have 5 more, how many x's do we have? So we have 6x is equal to 24. What times 6 gives you 24? Y'all be nice. That is correct. X is equal to 4. The next 2 problems are, oh, nope. Sorry. I shouldn't have boxed it. We're not done. The problem didn't ask for X. The problem asked for Y. So every single problem that you do, you're going to solve for one variable, and guaranteed on TSI, on your test, on your quiz, it's going to also have X, or it's going to have 4 as an answer, but that is not the answer because it's asking for Y. So what you do is we're going to take that and you're going to plug it into either equation. You could plug it into this one, or you could plug it into this one. Which one do we want to plug it into? Okay, fine. So it says y is equal to 5x. So it's 5 times what we just figured out. So 5 times 4 is what? 20. That is your answer because it says, what is the value of y? Yes. So with the other one, question, she said, does it make the same thing with the other one? Yeah, let's pretend that you plugged it into this one. So this is saying like 4 plus what gives you 24. It would also be 20. So plug it into either equation. It doesn't matter. You'll get the right answer. So you've got to do the first step, and then you got to plug it into one of them. The last type of problem. So the last 4 problems that you're going to do, you're also graphing to find the intersection, but neither equation is in y equals form. Who likes to graph when it's given like this? Nobody, because you've got to do a lot of math to make it work. But there is a trick. And so I am going to teach you a trick. There is a trick to graph when you have this form. So what you're going to do is we're going to graph by using the X and Y intercept. So what we'll do, and I'll show you up on the board because I can't put my thumb on the screen and show you. So what we're going to do is we're going to cover up each one. So looking at just the first equation, if I cover up the Y, then I get 3x equals 15. So 3 times what gives me 15? 5. X is equal to 5. I'm going to cover up the X. So this is -5 times something gives me 15. Or 15 divided by -5. -3. I'm going to go write those down. So you will cover up one with your finger, and then you will cover up the other with your finger to figure out what is X and what is Y. So we figured out when we cover up the Y, we get 3 times 5. So X is equal to 5. And when we cover up the X, we figure out that Y is equal to -3. Let's do the bottom one. If we cover up the 6y, then we have 6 times x is equal to 30, or 30 divided by 6. What is that? So same, let me draw a box. I can get one. So if we cover up that and we're solving for x, we would just divide by 6. So what's 30 divided by 6? 5. And so for this one, makes it kind of easy because it's the same thing. When we cover up the x and we figure out that y is also 5. That is helpful because that means that I can go graph my first line. My first line, I'm going to have x is equal to 5. So on the x-axis, I'm going to go put a dot at 5. Y is equal to -3. So I go put a dot at -3. All I do is connect the dots. I'm going to do the same thing to graph my second line. I'm going to go put a dot at x is equal to 5. And I'm going to put one at y is equal to 5. Do the lines intersect? Yeah. So the answer is where? Okay, so this is one where it's tricky. Every time that we list our point has to be x and then y. So how far do I move in the x direction? 5. How far do I move in the y direction? 0. I don't go up or down at all. So to get to this point, I have to go 5 and then nowhere else. I'm already at the point. So 5, 0 is my answer. Did anybody know that little trick to graph lines when they're written in standard form? It's easy, right? It also is helpful for, like, if I asked you what is the x or the y intercept, when they're written in standard form, it sucks because one way to get the y-intercept is to rewrite it so that it's in slope-intercept form, but you don't even have to sometimes. All right, your job is to finish the worksheet. You're going to finish the worksheet. We're going to grade it. And then I'm going to pass out the quizzes in a moment. And you can also do your quiz corrections.